And you can see how the black is lined up on the top of the surface again, and that's what happens to the gold. Just sits underneath the surface, the real fine stuff. So what we do is we knock it back down into there. Do the same thing. And that gives that fine gold a chance to settle into that sand. And seeing how we worked real hard all day long trying to do this, don't get in a hurry to get this done. And we do this for testing. We really wouldn't do this if we were going to smelt this. If you ran a ore all day long, this is going to be your high-grade concentrates. Just dry them out, throw them in the furnace, and smelt them. Now, the gold that you get out of the ground is usually running somewhere between 76 and maybe 85% pure gold, which means if you got an ounce of raw gold that you got out of the ground, it means only about 75% of that ounce is really pure gold. On the off chance it may be 85%. So when you smelt it, what you're going to do is get rid of more of the trash, and a lot of it's going to be copper. And if you have silver, the silver is going to be with that dory bar. Now we're down to just a little bit here, and then what we're going to do is we're going to act just like we do on a table. We're going to gently knock it up, roll the pan around, and as you can see, there's my gold line. This band up here, and right here you see this dark stuff. That's not gold. There may be some gold in there, but that isn't your gold. Your gold runs from way down here all the way over to here. Now we'll look under the microscope. Now you can also see how fine this gold is, and that's the fineness that we're looking for. The bigger stuff is over here, the finer material is over here. So what we're going to do is look at this underneath the microscope so you can see the individual particles. That's some nice gold in it. That mesh size there, that you're looking at 6, 7 microns, 10, 12 at the most. Mesh size wise, you couldn't get it through a screen. 1,000, 1,500, something like that. But when it gets that small, it's not worth talking about mesh size. Dust particles, what you're looking at. Mesh material there, which is about 150 microns or so. So you're looking at 10 times the size of the pieces that you were just looking at. And that's the material right there that your normal gravity separation material, equipment will separate. So we catch that, and we also catch all the fine material. And the fine material, as you noticed in the pan, was a lot more there than there is in this big stuff. And this is big as far as we're concerned. 100 mesh is easy to catch. And that's the end phenomenon of what we've been doing all day long. We want to see that yellow stuff. This is the Impor. This is your lab unit. This one runs off of 12-volt DC. You can put it on a trailer, run it off your battery of your car. I'm going to show you how to run it. Basically, you got 12 volts. I'm running off of a battery charger here. And as you can see, it doesn't turn on right away. What you have to do is turn up the voltage. Running way too fast. Slow it down. Right in there is where you want it. Here's your water flow. This is going to be the one that we use for our ore. This is the one that just keep it clean so we can see what we're doing. What I'm going to do is feed a little bit of ore in here. Now our line should be right in here. Get your table wet. See how we have our riffles here? Okay, we're going to put some dirt in here. This obviously will not run as much as this, the M7. It's for doing 2 and 3, maybe 5 pound ore samples. You can see we've got the same thing as we had on the N7. Here's our black sands. And here's our gold line already. You can see I'm running it real slow. It's hardly hitting very much at all, but we still have our black line, we have our tails, and here's our gold. Can you see that gold line? And that's as simple as it gets. Now, I'm going to show you what happens when you turn it up too fast. The same thing will happen to this table and that table over there. If you start hitting too hard, see how your gold is disappearing? What it's doing is it's forcing the gold into this bar, and that isn't what we want. So we turn it back down. And there's our gold line again, showing right back up. Now you can see the same thing. We got this bolted down to a heavy table, but you can see it still wants to shake. So once you get it into a rhythm, that rhythm is what it likes. And once it gets into that rhythm, it will move things. So the better you have it bolted to the ground, the better. Gold right out from underneath the black sands. And that's what these tables are all about, getting that gold out of that black sand in a very short amount of time.
I think this one shows up better.
This is the 5 to 8 ton an hour table. What we're going to do is just turn it on and let it run just a minute. I'm not going to run any dirt on it. I'm going to show you the adjustments to it. The reason I have it set up right now, as you can see, I'm running my hydraulics over here off of a gasoline engine, which you can do, or what comes with a table normally is an electric motor. So if you're in a remote area and you needed to run off of a gasoline motor, you can without going to a generator. Hydraulic lines. This is your this unit right here is what controls how fast or slow this goes. And we'll just go slow here. I can see how slow I can make it go. This will run all the way up to about 500 RPMs, which is too fast. Now, a few things that we have here. There's a hydraulic motor underneath here that actually runs an eccentric that is controlled with this thing right here. What this part right here is for is to actually adjust the tabletop inside of the frame. You only adjust that when it's off, and you have to do that by hand so that you just turn it so that you do not move the table so far back that actually contacts the linear bearings that are underneath here with the shaft holders. If it does, it breaks something. Normally the most expensive part, which is the bearing. These two units right here are for actually the bump, and that is actually controlled on both sides so that once it's level in this direction, if it's off a little bit, you can actually adjust the bump so that you can get the ore to flow evenly and come up the table evenly on both sides. There's rubber pads in between the two plates, and that's what this adjustment's for. Okay, this is the feed tube. This is actually what you pump your fluid, your ore slurry into, and then it's got notches on the bottom that actually feed it all the way across the table. Now, moving that out of the way, you can see this is our riffle pump area that we were talking about was plastic on the other one. It's actually two metal tube rods here. The ore actually has to go underneath here and over the next one. So here's your float again. It cannot get past your float. Your float gold will not go off the table. This is just set up in a general area. If you actually move this riffle bar towards this end, which is your concentrate end, you will make more concentrates. In other words, out of 5 tons, you can make 500 pounds, or you make 5,000 pounds. You move it up this way, you're getting to the 5,000. You move it down this way, you get to the 500. And then, like I said, these are all bolted down, and it's so that this piece is flat and level all the way across the table. Now, as you can see here, this matting is installed on the M10. This is where the V's come from. You got your fine material down here in the V. Any large material cannot get to it, so that you don't have a problem with oversized material in your ore feed, so that your fine gold is still coming out the back. And in this case, to this piece right here is your discharge. This one right here. This is your discharge. This is your concentrate discharge right there. Now, you can see I just have it rolling back and forth right now. I don't have very much on it. And you can see that the trailer that I have on it is only about, 15,000 pounds. Now, to give you an idea what happens if you don't have this down real tight, as you can see, the trailer is moving. It actually takes about, if you were going to run 8 tons an hour on this table, you need to be looking at about 8 to 12 tons of concrete underneath it to hold it down. The more concrete, the better. Because you have an awful lot of force here moving back and forth. And once it gets into the rhythm, that rhythm is what we work very hard to get, so that we have this smooth action back and forth. So there is no bouncing. So what we have is that whole momentum moving back and forth and stopping when it gets to this end up here. Well, if it's not bolted down to the ground sufficiently, it will move something. And you don't want it to take the table that you want moving. That is just about all on the M10. Gives you an idea what it's for, how big it is. Like I said, you're going to be running somewhere between 2 and 3 tons an hour minimum on this table just to make it work right. 5 to 8 tons an hour is what it's rated at. You would actually take this material off the table, run it right directly onto an M7, so you could take basically 2,000 pounds of material off this table as a primary concentrate right onto an M7 in an hour, so that you're running from, let's say if you were running at 8 tons an hour and you were pulling out 2,000 pounds an hour, that's only a 4-to-1 concentrate, right? No, yeah, what? 8-to-1 concentrate, I'm sorry. It's an 8-to-1 concentrate which runs right onto an M7, which runs the same hourly rate. So what you have is you're running 8 tons an hour right here. You're running right onto an M7. You are now making a concentrate that maybe is 20 pounds out of 8 tons. Very simple, very quickly. Thank you.